So I'm Bruno, head of compute platform at Rocked. I want to talk about how we use AI, Agentic AI and Kubernetes MCP server in our investigation and remediation process. So it's 3 a.m. All of a sudden, you have an increase in the error rate. Latency is going through the roof. P1 incident is declared and the on-call engineers are getting paged. Sounds familiar? And then people start asking questions. Did someone deploy something? Who owns this service? Is it a cloud outage or vendor outage? And you have a lot of questions. It's very noisy on the communication channel and no one's got an answer. So it's not a data problem. The data exists already. It's in different systems. It's a fragmentation problem. So if you have a problem in your Kubernetes server, like a bad deployment, you have to log into your Kubernetes cluster using kubectl. You probably have to switch context, find the correct cluster in the correct environment. Then you need to find the pods. Is it in a crash loop? Is it a bad state? Then you have to go to your observability stack. You have to remember who was the owner of the pod, what is the service, the team owning in which namespace, in which cluster. You have to start filtering to find the logs, the metrics. Then once you've got something, you have to go to your CI/CD pipeline. First, you need to find the pipeline, who is owning the service, which version was deployed by who. Then you have to go to Git, find the PR, so on and so forth. You also need to understand your upstream and downstream services. Is it a problem with the database? Is it something, another system applying back pressure? Then on the communication channel, they usually have a communication channel and people asking questions. What is the status update? Do you have an ETA for the fix? You have several people doing investigation at the same time, sharing links. It's very chaotic. I guess everyone in the room is familiar with that. So how can we make this better? So MCP, I'm sure Ron's heard a lot about MCP these days. Basically, you have an MCP server that will expose a set of tools. You have for every tool a name, description, and a JSON schema. And the MCP client on the other side can do the service, so the tool discovery, do argument generation based on the intent of the customer, of the user, and then return raw data for processing by the LLM. If we apply that to Kubernetes, so Kubernetes has several MCP servers that are open source. At Rocked, we use the one by Flux 159. This one supports multi-cluster setup. So you have one MCP server that can connect to different clusters in different service tiers, like dev, staging, production, different regions, and supports multi-cluster. So you can connect to one endpoint and then connect and start querying your different clusters without having to switch credentials or context yourself. It supports some advanced functionalities. So integrates with Helm. If you want to uninstall, do a rollback, you can do that via the MCP. You've got read, write, and destructive actions as well, and an authorization-based system. So you can control who's got access to what. So if you start pointing your ID or CLI agent to the Kubernetes MCP server, you can start asking questions in plain English. For instance, why are payments failing in the US East region? The tool will be smart enough to map the US East region to a kube context. So it will understand which Kubernetes cluster you are talking about, and then start fetching the pods for that specific namespace. It may come back with pod in a bad state. It will then iterate from there, find the pod logs, the events. It may find out that some of the pods are in crash loop because there is an OM. It will go back then and iterate and ask about the deployment. What is the deployment or Argo rollout, whatever you use owning the pod? What was the last time it was updated? What is the version? And then can automatically switch to other MCP tools. If you have anything in your ecosystem, go to the pipeline, observability stack, and do the root cause analysis for you. This will take under 2 minutes. If you have to do it yourself, I'm sure it will take more time than that. So now we don't want to just have Kubernetes MCP. We have a complex infrastructure. We run databases, so we have an MCP for CI/CD, one for the observability stack. We use Argo, Cassandra, Kafka, Trino, and a lot more. Even the cloud providers have their own MCP. So we use an MCP gateway. So the Agent Gateway project, which is a Linux Foundation project, acts as the gateway that can proxy the request to the different MCP tools that you have. So if you start deploying more MCP tools, you can register them under the single gateway, and your agents only have to talk to the MCP gateway. It does a lot more than that. It's also an LLM gateway, an agent gateway, but it's not the purpose of this talk. Meaning here you have just one entry point for all of your queries. It has also authentication and authorization. So when you have an agent talking to the gateway, you can then pass the credential of the agent down to the other MCPs. So you can act on behalf of an agent. So how does it work if you want to integrate this in our investigation loop during an incident? So first, what we did is to deploy a lightweight component in every single Kubernetes cluster that we have, that we detect events. If we have pods in a crash loop, an OM, or these kind of bad pod statuses, that will trigger an autonomous loop. So it will be an agent that can start reasoning. So it will understand based on the context which tools to use with which parameters. Then based on the response of the tools, it can act and then verify the root cause. And it can iterate several times. We have a token budget in place because we don't want to have a cost blowout, and a maximum number of iteration as well. So the agent will stop once it has a high enough level of confidence it found the root cause of the problem, or if the token budget is exhausted. Then at the end, we are going to compile the results, the root cause analysis with the evidence chain back to the user. And we post that either in the incident thread or on the chat or wherever. And the user can vote or put a thumbs up, thumbs down on the root cause analysis. And we keep that for later post-analysis, so we can improve the system. So what's next? We have an agent, but it's not good enough. We need to have more agents. We created Scotland Yard, which is actually a set of different agents with different purpose. So the way it is now, in the cast of agent, first we have the commander. This one has a 1 million token context, so it's quite wide. That is the one that is triggered when we start an investigation, whether it's coming from a monitor being triggered, it's coming from the chat, it's an event that we capture. It will start planning 2 to 3 different investigations. So we have internal prompt in Markdown that are version that we use to dispatch to the agent for the investigation. Then we have investigation agents. We have Sherlock, which is the main investigator. Same thing, it's got a 1 million token context. It can use all the MCP tools available in read-only mode and do the root cause analysis. We also have a light investigator, which has a smaller context and access to less tools, but it will be much quicker to run. Then we have 2 tools at the bottom, detection and remediations. These ones are not agentic AI. It's very deterministic, but it's based on, so for the detection, this one is the one I mentioned before that we drop in every cluster just to start triggering event and a full loop. And the remediation, this one is to take actions. So it will be a trigger to say we need to scale down this deployment, we need to patch to increase memory requests or whatever for specific scenarios. And the last one is Watson. This one is very important, that's the self-improvement loop that we have. So for every investigation that we run, we capture the user feedback and then we analyze everything. So we need to understand the anti-patterns that we have, any tool misuse or anything wrong. Sometimes the LLM can be very confident they found something and very convincing, even if they are wrong. And we have some cases where people were really confident as the LLM they found the root cause, and it was totally wrong and going totally off track. So that's the kind of feedback we need to get. Lessons learned. We learned a lot of things on the way. So the key things that I want to share. First, we need to have the guardrails from day one. Very important that you make sure that the access at the MCPs is read-only and you've got proper authorization in place and telemetry. Make sure you have a token budget for everything, that you can audit all the tools that you use, and that you capture everything in your logs, APMs, and metrics. Also provide skills and prompts, not just for the agents, but also for the people, for the engineering teams. Once you start exposing a Kubernetes MCP server, they will start asking questions. You want to present them with all the naming conventions that you have internally in your company, or how you name the clusters and the environments, what is stage, what is production. So that will make everyone's life easier. Some of the failure modes that we hit, or hallucinated tool calls, sometimes using the wrong tool to do something. So we have to tell the agent, Sometimes this tool is specific for this scenario. Don't use it for anything else, or prefer this tool over this one. Overconfident root cause analysis on ambiguous signals. Sometimes to investigation, the right one will have a lower confidence index than the wrong one. So we had to kind of tune all of this. For the remediation part, always start with very simple scenarios. Don't try to tackle anything complex or ambiguous. Start with something like pods ORMing. You just have to bump out the memory request. Start with something that simple, and then build from there. And MCP permissions and agent identity. I highly recommend using an MCP gateway. If you're not doing that today, try one. It's very useful. Like if you add more tools to your ecosystem, you don't need to propagate and share the endpoints and credentials with everyone. Just register under the gateway, and it magically appears everywhere. That's it.